Tanker Cargo Quantity Calculations. Basic Course. This video is about basic of oil cargo quantity calculations. It consists of two parts, basic facts and detailed explanations. Part 1. Basic Facts. Final goal of cargo quantity calculations is to find cargo volume at standard temperature and cargo weight in tons. Volume and density of crude oil and oil products depend on temperature. Higher temperature, bigger volume and smaller density, and vice versa. Cargo weight does not change with temperature and remaining same. Two different systems are used for calculations: metric system, volume in cubic meters, density in tons per cubic meters and temperatures in degrees of Celsius, and imperial system, volume in barrels, API gravity and temperature in degrees Fahrenheit. Internationally recognized standard temperature for cargo quantity calculations is 15 degrees Celsius or 60 degrees Fahrenheit. Simplified calculations sequence. Find observed volume of cargo in each tank using ship's tank ullage tables. Find volume of cargo at standard temperature. Convert volume at standard temperature into weight in tons. Find total standard volume and weight for whole ship. Part 2. Detailed explanations. Detailed cargo calculation sequence. Measure ullage, temperatures and free water in each cargo tank. Get ready on board quantity report prepared by cargo surveyor before loading. Obtain cargo density from loading terminal. Use ship's tank ullage table to calculate total observed volume for each tank. Calculate free water volume for each tank. Deduct free water volume from total observed volume for each tank. This number is gross observed volume. Obtain volume correction factor (VCF) from a ASTM table for each tank. Multiply gross observed volume by volume correction factor and get gross standard volume. This is volume of cargo at standard temperature. Add free water volume to gross standard volume. This is gross standard observed volume. Deduct cargo on board quantity from gross standard observed volume and get standard loaded volume. Find WCF, weight correction factor. It depends on cargo density at standard temperature and equal for all tanks. Multiply standard loaded volume by weight correction factor and get weight of cargo. Congratulations! You found standard volume and weight of cargo in each tank. Last, find total weight and standard cargo volume for whole ship. Are you still confused? Let's try again. But this time we use ullage report sheet. First, let's find total observed volume for each tank from vessel's tank tables. Calculate free water volume for each tank and enter in Ullage report. Deduct free water volume from total observed volume and get gross observed volume. Enter density and average temperature for each tank. Find volume correction factor. Do not interpolate. Always round temperature and density to nearest increment in tables.
Multiply volume correction factor by gross observed volume. This is gross standard volume. Now, use Table 13 to find weight correction factor.
And finally, you calculated weight of cargo in metric tons. Now, repeat all steps for each cargo tank and find totals. Congratulations! You calculated total weight of cargo in metric tons and its volume at standard temperature. However, job is not completed yet. Transfer totals to small tables below main calculations table. Table to the left is for calculations of loaded oil. Table to the right is for calculations of total received volume. Difference between these two tables is free water. Add total free water to gross standard volume and get total calculated volume. Deduct OBQ from gross standard volume and get loaded oil volume at standard temperature. Deduct OBQ from total calculated volume and get total received volume at standard temperature. Weight of cargo was calculated in metric tons. Let's calculate weight of cargo in long tons. goal is reached. You know how to calculate standard volume and weight of oil cargo in metric and long tons. However, that was basic course only. Still lot of thing to learn out there. Watch my next video, Oil Cargo Calculations, Advanced Course. We will learn what ASTM tables use and when. How to gauge cargo tanks correctly. Importance of ship's trim for cargo calculations. Is cargo surveyor works for ship, or not? And many other hints and tricks. Advanced Course Chapters. How to ullage cargo tanks correctly, trim, ASTM tables. What table to use? Vessel experience factor, how to work with cargo surveyor, how to deal with ship shore cargo figures difference. Chapter 1, How to ullage tanks correctly. Before you go on tank deck for ullaging, print cargo tanks ullage report generated by remote tank gauging system. Compare UTI readings with computer-generated report when gauging tanks. Though remoted gauging system readings are not exactly matching UTI readings, by comparison of these two, big errors will be avoided, like recording ullage 2.74 meters instead of 2.47 meter. If few error like this happening, then big difference between ship and shore figures will occur. Use same UTI for tank gauging in loading and discharging port. Make sure UTI has valid calibration certificate. Verify UTI temperature readings by independent thermometer. Compare water temperature in bucket of water by UTI and independent thermometer. Do not allow any distractions during tank gauging. Errors leads to significant commercial and reputational losses. Identify gauging ports correctly. Cargo tanks has 2 or 3 sounding ports. These used to check if cargo remaining on board after discharging. Do not confuse them with ullage port. Tank deck around ullage port always painted in black. Height of tank and tank name always stenciled near ullage port. Chapter 2, Trim. Tank ullages tables are calculated for vessel at even keel. If vessel trimmed, level of liquid at ullage port increases. Therefore, when ullaging tanks, Vessel must be on even keel or trim corrections must be applied. Do not use loading program calculated trim for ullage report. This trim often very inaccurate. Usage of trim, calculated by loading program, may lead to considerable difference between ship and shore figures. Loading program never properly calculates hull deflection. Therefore, actual drafts often considerably different with calculated drafts. Also, longitudinal center of gravity of deadweight constant never calculated before loading, so it loading program use approximate numbers from previous voyages. This is another reason for low accuracy of draft calculated by loading computer. Very important. Check actual drafts before tank ullaging. As alternative use draft gauges. It is good practice to compare actual draft with draft gauge and calculate error. Apply corrections to draft gauges readings. Use of corrected draft gauges readings will save lot of time and efforts in determining correct trim. It is critically important to use correct trim value. Example. On Suez max size tanker, 2 cm of trim by stern will decrease ullage in average by 80 barrels. There are 12 cargo tanks. As result, 2 cm of trim will cause 1056 barrels dispute with loading terminal. If trim error is 30 cm, then about 16,000 barrels difference will appear. Use following ASTM tables if loading terminal provide a PI cargo density. The vessel experience factor is a loading cargo history ratio used to improve the accuracy of cargo quantity calculations. It reflects the difference between ship and shore measurements over multiple voyages. It's calculated by comparing the total calculated volume (TCV) of cargo on the vessel to shore-based measurements. VEF is typically applied to the whole vessel, not to individual compartments or tanks, and is used to adjust ship measurements only. Some voyages must be excluded from VEF calculations. Shore figures are not available. Voyages first one after dry dock, cargo received from another ship during lightering, voyages prior to major structural modifications, cargo was loaded in parcels, loaded less than 75% of ship's capacity. How to apply VEF? Divide total calculated volume by VEF. Basically, though cargo surveyor is third party, he protects ship, not terminal. Ullage report produced by cargo surveyor is used as third-party conclusive evidence in case of cargo quantity commercial dispute between ship and loading terminal. So, cooperate with cargo surveyor, do not argue. If there is difference between vessels figures and surveyor figures, it means that somebody made mistake. And nothing else. Use this situation as an opportunity for double check. Vessel and surveyor have exactly same ullages and temperature readings and density. Vessel and surveyor use same tank tables, ASTM tables and method of calculations. Consequently, results of calculations must be same, or very little difference occur due to rounding of numbers. It is easy to find who made mistake, ship or cargo surveyor. First, check TOV. If there is a difference, check TOV for each tank and find error. If TOV are matching, check GSV. If different, check GSV for each tank. If difference found, check every tank temperature and corresponding VCF, and last, check if WCF correct. Easy. It takes few minutes to find error, but it takes much more time for useless arguments due to 10 barrels difference. Difference between ship and shore cargo figures always exist. Critically important to understand that shore cargo figures is always used for bill of lading. Vessel checks quantity of cargo received on board, just to verify bill of lading figures provided by loading terminal. It is widely accepted that shore figures are more accurate than ship's figures, therefore shore figures used for cargo documents. Ship has very complex geometrical shape, so it is difficult to calculate exact volume corresponding to ullage. Shore tank's shape is simple cylinder, easy to calculate its volume. Second factor is trim. There is good possibility that not accurate vessels' trim was used for calculations. Shore tanks never have trim. Another reason difference between ship and shore figures is accuracy of flowmeters used by loading terminals to determine volume of cargo pumped to the ship. Standard flowmeter accuracy is less than 0.3%. So, industry acceptance criteria are less than 0.3% difference between ship and shore figure. What to do if difference is more than 0.3%? Vessel must apply VEF to total calculated volume and compare ship's figures corrected by VEF against shore figures again. If difference still more than 0.3%, then prepare letter of protest for difference between ship and shore cargo figures. And last, inform captain. He will contact vessel's commercial operator and report about issue. Best way to report is to email draft copy of letter of protest for cargo figures difference. When making initial report, signature of any third party on LOP is not required. Commercial operator will provide further instructions to the ship. LOP for cargo figures difference must be always issued, no exemptions. Even if difference between ship and shore only 0.001%.